Hi everyone. In this video we'll go through additional problems on symmetric and skew symmetric matrices. Now let's take few exercise problems, right? For the matrix A, which is given here, verify that A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetric matrix. So we'll have to prove, right? Let's take A. Let's first find A transpose. A transpose is 1, 5, 6, 7, right? This is A transpose. Now we will simply add both of this. We'll have to prove A plus A transpose is symmetric matrix. So we'll add both of these matrices. What's going to happen? We're going to get 2, 11, 11 and 14. Now let's call this as matrix P just to make it easier, right? Now let's take transpose of P. P transpose is equal to 2, 11, 11, 14. I'm going to get the same matrix even after taking transpose. So P transpose, same thing as P, right? Both these matrices are same. So since P transpose is equal to P, P is a symmetric matrix, right? P is a symmetric matrix. And what is P here? P, we assume that it's A plus A transpose. So therefore A plus A transpose is a symmetric matrix. Now let's prove A minus A transpose is a skew symmetric matrix. Same way. So we know A and A transpose. Let's subtract them. A minus A transpose. Let's call this as Q, right? Let Q be A minus A transpose. So now let's subtract. A minus A transpose is 1 minus 1, 0. 5 minus 6, 1. 0 minus 1. 6 minus 5, 1 and 0. So you're going to get this. This is the matrix that we are going to get. Okay, this is nothing but A minus A transpose. Now let's take the transpose of this, Q transpose. What is Q transpose? Let me interchange. So I'm going to get 0, 1 and minus 1, 0. Right? Now let's take minus outside. Let's take minus outside, right? For this, what will happen if I take minus outside? It's going to become 0. Signs are going to get swapped. Plus 1 is going to become minus 1. Minus 1 is going to become plus 1 and 0. So now if you notice, what is this matrix? This matrix is nothing but Q itself. Minus Q. So we got Q transpose is equal to minus Q. Now this satisfies the condition for skew symmetric, right? Since it satisfies the skew symmetric condition, Q is skew symmetric matrix. Now what is Q? We assume that Q is A minus A transpose. So instead of Q, we'll write A minus A transpose is skew symmetric matrix. Let's take another example where we have to express this particular matrix as the sum of symmetric and skew symmetric matrix, right? We proved this in the theorem, right? What does the theorem state? That matrix A is nothing but half of A plus A transpose plus half of A minus A transpose. So this is Q and this is symmetric. This is what we have to prove now. We'll have to prove that this is symmetric, this is Q, and when you add both of this, you're going to get matrix A. That's all we have to do. So what we'll do, we'll first find A transpose. A transpose is 3, 5, 1, minus 1. This is A transpose. Now, let's assume that P is equal to half of A plus A transpose. Let's assume that this is P and Q is half of A minus A transpose. Let's add A and A transpose. This is A. A is equal to 3, 5, 1, minus 1. Let's add both of these. When we add both of this, we're going to get 6, 6, 6, 6, 6, minus 2. And then we're going to multiply this with half. So we're going to get P is equal to half into 6, that is 3, 3, 3, minus 1. Right, this is matrix P. Now let's take transpose. Take transpose. We will get P transpose is equal to 3, 3 and 3 minus 1. So if you look at both of these, P transpose is equal to P, right? Say this is 1 and this is 2. From 1 and 2, P transpose is equal to P, correct? Therefore, P is a symmetric matrix. Therefore, P is a symmetric matrix. And what is P? We'd assume P to be half into A plus A transpose is a symmetric matrix. Now we'll do the same thing for Q. We assume Q is half of A minus A transpose. Now let's subtract matrix A and matrix A transpose. So these are the matrices. We'll have to subtract them. So we're going to get, when you subtract, 3 minus 3 is 0, 5 minus 1 is 4, 1 minus 5 is minus 4, minus 1 is minus 1 plus 1, which is 0. And then we'll have to multiply with this half. So we'll get 0, 2, minus 2 and 0. This is matrix Q. Now let's take transpose. Taking transpose, we get Q transpose is equal to 0 minus 2 and 2, 0. Let's take all the elements are same, right? Let's take minus sign outside, right? If you take minus sign outside, you're going to get 0. Signs are going to get swapped. Minus 2 is going to become plus 2. This is going to become minus 2 and 0. Right? Now if you notice, this matrix is exactly same as matrix Q. It's nothing but minus Q. So Q dash is equal to minus Q. So this satisfies the condition for skew symmetric matrix. Therefore Q is a skew symmetric matrix, which means what is Q we assume? Q is half of A minus A transpose. So half of A minus A transpose is skew symmetric matrix. Our last step of the problem is we'll have to prove this expression, right? This is the last step. We'll have to prove this matrix A is equal to sum of these matrices. Now we got this matrix and we got this matrix. This was P and this was Q. Let's add P and Q together, right? Q we got as this one, right? This is Q matrix. Now we have taken matrix P and matrix Q and we'll have to add both these matrices, right? And when you add, we need to check if we'll get matrix A, right? Let's add them. 3 plus 0 is 3, 3 plus 2 is 5, 3 minus 2 is 1, minus 1 plus 0 is minus 1. So this is matrix A. So after adding, we got matrix A. So this is same, right? This and this is same. So this resultant matrix and matrix A is same. So therefore, we'll have to conclude that matrix A is a sum of symmetric and skew symmetric matrix, where A is 3, 5, 1, minus 1. Let's take another example where if AB are symmetric matrices of same order, then AB minus BA is a which type of matrix? We'll have to identify the type of matrix. Is it skew symmetric matrix, symmetric matrix, zero matrix, or identity matrix? Now, let's get started. So, AB minus BA, we'll have to find what kind of a matrix this is, right? What they've told is A and B are symmetric matrix. A and B are symmetric. That means A is equal to A transpose is equal to A because it's a symmetric matrix. B is also a symmetric matrix, so B transpose is equal to B. Now, given these conditions, we'll have to find what is the matrix. We'll have to find what matrix is AB minus BA. So what we'll do is, let's take transpose of AB minus BA. Let's take transpose of this. So we'll get AB minus BA overall transpose is equal to, what will happen? By property, we will get AB transpose. We can split this as minus BA transpose. We can split this like this, right? So what is AB, the whole transpose? It's nothing but B transpose A transpose. So we have the property, right? AB transpose is nothing but B transpose A transpose. So this B and A will get swapped. So we'll have B transpose A transpose minus A transpose B transpose, right? Now what is B transpose? Nothing but B. A transpose is A transpose is A and B. So what did we get? BA minus AB, right? So what we can do, we can take minus outside. Minus, if you take outside, you can write it as AB minus BA. So we got minus of AB minus BA. That is this one. We got this, but with a negative sign. Nothing but, so if you had assumed that this entire thing was a P, right? If this was a P, then this would have been P transpose is equal to minus AB minus BA. That is, assuming that P is equal to AB minus BA. So now P is equal to AB minus BA. This is nothing but minus P. P transpose minus P, which is nothing but it is satisfying skew symmetric matrix condition. So therefore, AB minus BA is skew symmetric, and the answer is option A. This is the correct option. This is the answer. Let's take another example. If A is equal to this particular matrix and A plus A transpose is I is nothing but an identity matrix, then the value of alpha is. So we'll have to find the value of alpha. 4 options have been given. We'll have to see which is the right value for alpha. So what we'll do is, we will find out A plus A transpose. A plus A transpose. If you, this is A transpose. You add both the matrices and equate it to identity matrix, right? When you equate it to identity matrix, because these two matrices are equal, 2 cos alpha is equal to 1, right? 2 cos alpha is equal to 1. 2 cos alpha is equal to 1 means alpha is equal to 60 degree, because cos 60 is half. Cos 60 is half. And what is 60 degree? It's nothing but pi by 3. So correct answer is option B, which is pi by 3. So I hope the concept on symmetric matrices, skew symmetric matrices and transpose is clear. Thanks for watching.